All right. We are going to look at conditional probability. Conditional probability is the probability an event has occurred given that another event has already occurred. Given something, the probability of something else. Okay? Oh, maybe I should put it up so you can actually write it down. Vocab word. The probability that event B will occur, given that another event A has already occurred, is conditional probability. Okay, so here's a bunch of student committees at a high school. There's 115 total kids involved in student committees. Okay, now what's the probability that a member of the art club is selected at random is a junior? So what we're doing is figuring out the probability with two things happening. Given that they are in the art club, what is the probability that they're a junior? Well, the art club is right here. How many total people are in the art club? 58. So given the 58 people, how many are a junior? 16 of the 58, which is 8/29. Okay? What's the probability given that a kid is a junior? What's the probability that they're in the art club? Well, how many juniors do we have? 40. How many of those are in the art club? 16. So that is divided by 8, 2/5 of a chance. Okay? Now, what is the probability somebody is in drama? Just plain and simple. What's the probability of being in drama? 17 out of 115. You guys are so smart. I love you guys so much because you guys get this right away. The probability that they're just in drama is the probability out of everybody. But if I would say, what's a probability that they're a senior, given that they're in the drama club, then what is that?
8 out of 39.
Given that they're in the drama club, 8 out of 17. Given the 17 kids in the drama club, what's the probability that they're a senior? 8 of them. Okay. Let's do another one. The probability given that they're a senior, what's the probability that they're in the science club? Well, there are 39 seniors. How many are in the science club? 13. Okay, see how that works? Okay. So, what's the probability that they're a sophomore given that they're in the drama club? 3 over 17. What's the probability, given that they're a sophomore, that they're in the drama club? 3 out of 36. Are the sophomore in drama and the drama sophomore the same? No, they are not the same. Diego wonders how much sleep he gets if it's related to how much coffee he drinks in a day. For 10 weeks, he records how much coffee he drinks in the morning and how many hours he sleeps at night, round to the nearest hour. What's the probability that, given he sleeps 8 hours, that he will have drank 2 cups of coffee? Yep. Given that a total of 8 hours, given the 8 hours, what is 2 cups? Now, what is P of 8 hours, 2 cups? Given that he's drank 2 cups of coffee, what's the probability he has 8 hours of sleep? 4 out of 24. Okay? Okay. To figure out their dependent or independent events, if P sub A is the same as P sub A slash B, then they are independent. Or if P sub B is the same as P sub B slash A, then they're independent. Okay? So the first letters match in each. Okay? So what is a black vehicle and a van independent or dependent? Well, the probability. So let's look at the probability of black and see if that is equal to the probability of black given it's a van. Well, what's the probability of having a black vehicle? 13 out of 22. What's the probability of, given it's a van, it'll be black? 3 out of 3, which is 100%. Are those equal? No. Okay. If we would go probability of a van, seeing equal if it's probability of a van, given it's a black vehicle, how many vans are there? 3 out of the 22. What's the probability that, given it's a black vehicle, that'll be a van? Are either one of them the same? No. So they're dependent upon each other. Okay. I think you only have to do one. Oh, and you have to do both of them. But I think once one proves false, then yeah. If you get one to be equal, then you got to check the other one to make sure that's equal as well for it to be independent. Yeah, then it's dependent. Yep. So let's look at this one. Student is a girl, student's taking French. So the probability of a girl has to be equal to the probability of a girl, and given that she's in French class, or the probability somebody's in French class is equal to the probability of the French class given that they're a girl. What's the probability that a person's a girl in that school? 300 out of 500, or 3/5. Given that they're in French class, what's the probability that they're a girl? 45 out of 75, which is a 3 out of 5 chance, right? So these are equal. Let's do it the other way. What's the probability of being in French class? 75 out of 500. What's the probability, given that you're a girl, you're taking French? Okay. So I know 25 goes into each of these 3 and 20 times, right? 15 goes into each of these 3 and 20 times. So they're independent of each other. Okay. G and F are independent events. Okay. Now for the ones that I don't understand as well. We won't have many of these because if I don't understand them very well, I'm not going to force you to try to understand them very well. But we're going to do the best we can. Given that a student plans to attend a band concert and, so we multiply, is a fan of the group, okay? 70% of the students plan to attend the concert. So that's 0.7. We have to multiply it and is a fan of the group, okay? 80% of the students who plan to attend are fans of the band. So then that's times 0.8. Because if you plan to attend and you're a fan, that's 0.7 times 0.8, which is 0.56. So 56% of the student, 56% of the students that plan to attend the concert are fans of the group.
Wouldn't you have to subtract those since you're technically double counting? 10%? Because there's two students who plan to attend, and then, see what I'm saying? Wouldn't you have to subtract 10.1?
What's the probability that a surveyed student plans to attend a band concert and is a fan of the group? So 70% of the students plan to attend. So let's say there's 100 students in the high school. 70 of them plan to attend. 80% of the students who plan to attend are fans of the band. So out of the whole high school population, 56% of the students who 56% of the high school students are both planning to attend and are fans of the band. Yeah. Like I said, not the easiest to understand. Okay. What is the probability that a surveyed student plans to attend but is not a fan of the group? Well, 70% still plan on attending. 20% of those who attend are not fans of the band. So I would say 14% of the high school population are, so 14% of the kids were surveyed. They plan to go, but are not especially fans of the group. Okay. All right. A marketer is looking at cell phone statistics, trying to figure out, okay, which is the best model basically to push. Okay. Now, 46% of the population of the country searched for a certain type of phone, which is brand W. Okay. Of those 46%, 16% also bought the phone if once they searched that phone. So if you take 16% divided by 46% or 0.16 divided by 0.46, 34%, 34.8% of the people who searched wound up buying that phone. Okay. Only 32% of the country searched for product X, but of those 32%, 14% decided to buy. So if you take 14 divided by 32, you get 43.75%. So there must be good enough features on phone X that a larger percentage of them, once they search them, decide to buy X than W. Okay. And so that's that. I'm just going to call that good there. Okay. So the probability that an event will occur given that another event has already occurred is conditional probability. Okay. So conditional probability is a probability of both A and B happening given that A has already happened. Okay, so that's conditional probability. I will put the assignment out there, and if you have troubles, I will help you with it. All right, there we go. Boom.